Hi viewers, in this presentation I'll be explaining various objective type questions on Ohm's law and resistance. Let's begin the first question. What is resistance? First option, it is the ratio of current flowing through the conductor to the potential difference. So they have given here as I divided by V. And second is sum of the potential difference across the conductor, that is VA plus BV, or suppose if you consider this A and B are the two ends. Okay, so sum of the voltages of these two ends, that is the potentials, to the current. So we need to divide by current. Is that correct? The product of the potential difference across the conductor to the current flowing through it. Product of VA into VB divided by I. Is that correct? No, it is, let's see the other one, ratio of the potential difference across the conductor to the current. So last one they have given us ratio of potential difference across the conductor to the current, V by I. So this is correct. Resistance R is equal to V by I. Okay, according to the definition. So the correct option will be option D. Next question. What is the unit of resistance? Unit of resistance they have given as option A, ampere. Ampere is the SI unit of current. Ohm is the SI unit of resistance. And watt is the SI unit of power. And volt is the SI unit of potential difference. So option B is the correct answer. SI unit of resistance. Which of the following statements is or are true about the relation between voltage and current across the conductor? So what is the relationship between the voltage and current? We know the relationship between voltage and current is V is equal to I into R. So how did we get? We know the voltage is directly proportional to current, or current is proportional to voltage. From that we get V is equal to I into R. This is the thing. So let us see which will be the correct option. Option A is voltage is directly proportional to current. Okay, that's fine. Next one, voltage is inversely proportional to current. Do we get? Voltage is inversely proportional to current. Inversely proportional to current. No, that's wrong. Next, there is a relationship between voltage and current. There is no relationship. See, there is no relationship between voltage and current, it seems. There is relation, which is V is proportional to I. Okay, so this is wrong, this is wrong. So the correct answer is option A. Voltage is directly proportional to current. Option A is correct answer. Ohm's law states that the relationship between which of these two? So what relationship about which two quantities the Ohm's law relates? We know that it is the relationship between voltage and current, linear relationship between voltage and current, isn't it? So option A is electric current and resistance, I and R. It is a relation between I and R. It is a relation between electric current and work. No. Electric current and potential difference, V and I. Yes, correct. Option C is electric current and electric charge. No. Then the option C is the correct answer. Option C will be the correct answer. It's the relationship between voltage and current. Fifth question. So this is the given diagram. So in the above image, a student carries out experiment and plots the VI graph of 3 samples of nichrome wire with resistance R1, R2 and R3 respectively. Which of the following is true? See, in this diagram we can see what do we infer. See here, when we take the slope of this, so let us draw a line like this. Let us take the slope of this particular graph. So when we take the slope of this particular graph and take the slope of this particular curve and the slope of this particular curve. Okay, so here what happens, this will represent the voltage V. This will be the voltage difference of these two. So you find that voltage is almost the same, but you see here, what about the current? Current is, for this particular curve, the current value is less. Okay, current is less. This current, let us take it as less current. Okay, so I1 is less, and here I2, this difference, the difference in this current, when we take this particular slope, delta I of this is going to be lesser than this delta I3 when we take, okay, that is lesser than delta I2, and this current, see, this is delta I3. Delta I3, it's from here to here. Okay, so this is delta I3. So that when we take, so what is the difference of that? It is still greater. It is greater. So you find that the current is more here. Delta I3 is greater. So the difference delta I3 is greater than delta I2. Delta I2 is greater than delta I3. That means the least one is going to be I3. So we know resistance is equal to V by I. So here, if the current is decreasing, resistance will increase. So here, which current is less? So when we take delta V by delta I, which current difference is less? Delta I3 is less. So that means resistance R3, delta I3 is going to be less. That means delta I3 is going to be less, means R3 is going to be more. R3 is more. So the resistance R3 is more when compared to R2. R2 is more compared to R1. So we can say R3 is more than R2. R2 is more than R1. So R1 is having less resistance, least resistance. R1 is having least resistance. R3 is having highest resistance. So which option will be correct? Let us see. Option 1, all are equal. No. Option 2 is R1 is greater than R2 greater than R3. R2 is greater than R3. Okay. So here R3, third option, see, R3 is greater than R2, R2 is greater than R1. So R1 is the least, R3 is the highest, correct. So option C will be correct. Option 4, see, R2 is greater than R3, R3 is greater than R1. No. So option C will be the correct answer. Let us see. Option C is the correct answer. We know, right? So here which one is the R3 is more resistance, R2 is the less resistance. So we get R3 is more than R1. So therefore R3 is greater than R2 is greater than R1. So option C will be correct answer. Sixth question. Assertion and reason type question. Assertion is, if a graph is plotted between potential difference and the current flowing, the graph is a straight line passing through the origin. Yes. Assertion is correct. Reason is, the current is directly proportional to potential difference. Is that correct? Yes, both are correct. See here, this is the voltage and this is the current. Okay, so what is the relation between them? It's a linear straight line. Yes, of course, the assertion is correct. Reason is, current is directly proportional to voltage. Yes, according to Ohm's law, current is directly proportional to voltage. That's the reason they are linear. Reason is also correct. So we know assertion, both assertion and reason are true. Yes, reason is correct explanation of assertion. Yes, option A is correct. Let us go for option B. Both A and R are true and R is not correct explanation of A. No, it is correct explanation only. So it is not the option B. Option A is correct. Option C is A is true but R is false. No, both are true. So therefore these two options will not come. C and D will not come. So the correct answer will be option A. Okay. So the correct answer will be option A. Both assertion and reason are true, and R is the reason is the correct explanation of assertion. So now we'll go for 7th question. State whether the given statement is true or false. All devices obey Ohm's law. No, every device will not obey Ohm's law. Okay, certain devices that are there that will not obey Ohm's law. For example, semiconductors, arc lamps, and other thing, they don't obey Ohm's law. Okay, so therefore answer is false. All devices will not obey Ohm's law. Next statement. Resistance is the measurement of how much the metal opposes the electric current at a particular voltage. Yes. Opposes. Resistance means it is the property which will oppose or hinder. Okay, oppose or hinder the flow of current. Yes, that is correct. So it is true. What is the resistance of ideal ammeter? See, ideal ammeter usually when we take an ammeter, okay, ammeter should be connected in series. So if it has to be connected in series, so it should have low resistance. That is, practically speaking, it should have low resistance. But ideally speaking, we can say low in the sense it can be 0. If it is 0, then maximum current will be flowing. So therefore easily we can measure the current through that. Current through any equipment. Right. Next. What is the resistance of ideal voltmeter? See, ideal voltmeter, we say practical. First let us talk about practical voltmeter. So this is the voltmeter. It is connected. Voltmeter should be connected across a resistance. This is the resistance. It is connected across the resistance. Voltmeter, isn't it? So here the voltmeter will have high resistance. If it is having high resistance means it's having high resistance. So high resistance means the current flowing will be less and all the current will flow through this resistor. So easily we can measure the voltage across this resistance. Okay. So therefore it should have high resistance means ideally speaking it should have infinite resistance. That's the correct answer. What is the resistance of an air gap? So resistance of an air gap usually it will be almost high, almost infinite. It will be very high. The resistance of the air gap. Suppose if we have two cubes like this and this is the gap which is present, and the gap of these resistance when we consider it's going to be very infinite. Okay, almost infinite. Next question, 12th question. A wire carries a current of 0.1 amps. What is given? Current is given I, and they have given the resistance. What is the value of the resistance? 120 milliohm per meter. 120 milliohm per meter. What is the potential difference across 1 meter of the wire? So they have given the length also. So resistance per length is given and then current is given. So how to get only resistance? Resistance can be got by multiplying the length. What is the length given? 1 meter. So let us multiply 1 meter with this 120 milliohm so that we get resistance. So 120 milli is 10 to the power minus 3 milliohm per meter. Okay, so here it is 1 meter of the length. So you multiply with the 1. So you get this much. So this is the resistance. How to find the potential difference? Potential difference is V is equal to I into R. Okay, so what about I is 0.1, R is 120 milliohm. So this will be equal to, so we'll be getting, what is the answer? Let us find. So resistance is 120 into 10 to the power minus 3. This is resistance. Okay, and what about the current? Current is current is 0.1 amps. Okay, so we are multiplying that, so with that we get potential difference V. So it's going to be 12 millivolt. It's going to be 12 millivolt. The option is C. Option C is the correct answer. A voltmeter reads a 24 volt across a resistor and ammeter reads a current 3 amps through it. What is the value of resistance? How do you find the resistance? We know the resistance is equal to V by I, isn't it? That is voltage by current. Voltage is 24 and current is 3 amps. So when we divide, it's 8 ohm. Okay. So resistance R is equal to 8 ohm, which is the first option. Option A is correct answer. A voltmeter reads 24 volt across a resistor and ammeter reads 3 amps through it. What will be the current through the resistor if the voltage across voltage changes to 12 volt? See, first what we are doing, the voltage is, this is a resistor, you think. So voltage across this resistor, if it is going to be 24 volt, okay, and the current flowing through this, okay, the current flowing through this is 3 amps. Okay, it's 3 amps. What will be the current through the resistor? We need to find what is the current through the resistor if the voltage is changed to 12 volt. That means we need to find what is the resistance, this resistance value first. So how to find R? R is equal to V by I. V is 24 and I is 3 amps. So it is 8 amps actually. Okay, so this 8 amps is the resistance. Now the resistance is 8 amps, we know. So how to find current I? And voltage also we know. So we know V, we know R. How to find I? I is equal to V by R. So V is how much? Given as 12 volt. So 12 divided by 8. So you cancel this. 4s are 6 are, then 3 by 2. It's 1.5. Option B is the correct answer. Option B, 1.5 amps. 1.5 amps. A potential difference of 40 volt is applied across a resistance of 8 ohm for a period of 2 minutes. How much current is drawn? So what all the data is given, you see, voltage is given, resistance is given, and time is given as 2 minutes. 2 minutes means 2 into 60, that is 120 seconds. You are converting the minutes to seconds. And we need to find current. So how to find the current? I is equal to V by R, isn't it? What is V? V here is 40 divided by R is 8. Why they have given time? To confuse you. So 40 divided by 8. So you cancel it. You get 5 amps. 5 amps is the correct answer. Okay, 16th question. A potential difference of 40 volt is applied across a resistance of 8 ohm for a period of 2 minutes. How much a charge passes through the resistor? So here what we have to do is V, R, and T is given. Time is given. Time is 2 into 60 seconds. Okay, we need to find Q. What is Q? Right. So here how you will find current? I is equal to Q by T. Okay, do we know current? Yes. We can also find the current by V by R, isn't it? Okay, so from this how you will find Q? Q is equal to V by R. This T I can take it to the other side. So T. So this can be, what is V? V we know it is 40. What is R? What is R? R value is 8 and T is how much? 2 into 60. Okay, so you can cancel this. This is 5s are. So 5 2s are 10. 10 into 60 is 600. 600 coulomb is the correct answer. Okay, right. Now, what is the fixed resistance called? Fixed resistance, we call it as rheostat. No, rheostat is a variable resistance. Resistor is the correct answer. Key, no, it is not called key. D, it is not switch. No, the correct answer is fixed resistance. We call it as a resistor. Okay, that will not vary. A boy records that 4000 joule of work is required to transfer 10 coulomb of charge between 2 points of resistor of 50 ohm. The current passing through it is 2 amps, 4 amps, 8 amps and 16 amps. So what all the data is given we have to write. It is 4000 joule work is given, and then the charge is given. Charge is 10 coulomb. Resistor is given as 50 ohm, and we need to find out the current. So how to find the current? I. So we know I is equal to here what we have. So we have here work done and charge is given. Okay, WQ is given. So I is equal to V by R. But what is V? V is equal to W by Q. V is equal to W by Q. So we can write like this. How to find current? I is equal to, now W is how much? W is 4000. So 4000 divided by Q is 10 coulomb into R is 50 ohm. So we cancel this 0 and this 0, 0 and this 0. So 40 divided by 5 is 8. So answer is 8 amps. Okay, right. So 19th question, the resistance of electric bulb drawing 1.2 amps current at 6 volt will be. So voltage is given, current is given, we need to find R. So how to find R? R is equal to V by I. So what is V? V is 6. V is 6. What about I? I is 1.2. So you multiply numerator and denominator by 10, you will get 60 by 12, which is 5 ohm. Okay, option is B. That's the correct answer. It's deleted. Okay, 5 ohm. Which of the following is the correct mathematical expression for Ohm's law? V is equal to I into R, R is equal to VI, I is equal to VR, none of the above. Option E is correct. V is equal to I into R. Okay. Here, 21st question. From the above figure, state which law is expressed here. V proportional to I or I proportional to V, that is Ohm's law, no? So from this figure we get Ohm's law. No, Kirchhoff's law, Kirchhoff voltage law, Faraday's law, nothing. So option A is the correct answer, which is Ohm's law. 22nd question. From the above figure, name the physical quantity represented by the slope of the graph. So when you find the slope of this graph, what you will get? This is the slope you think. Take 2 points on the graph and find the slope. This is the slope delta y and this is delta x. Okay, so what is the slope formula? Delta y by delta x. What is delta y here? It is voltage here. So therefore we should take delta v, and this in the x-axis what we have current. So therefore it is delta I. Okay, so what will be slope? Slope is equal to delta v divided by delta I. So what is the relation? V divided by I is what? It is resistance. So option A is current, option B is resistance, option C is density, option D is none of the above. Answer B is the correct answer, resistance. Okay, the slope indicates resistance here. 23rd question, check the given figure and state the SI unit of the physical quantity that represents the slope. Just now we have seen. Slope is resistance. So what is the SI unit of slope? It's ohm. So watt, no. Option B, ohm. Option C, volt. And option D, ampere. The correct answer is option B, ohm. Ohm's law relates the current in a conductor to the potential difference across its ends. Is it true or false? Yes, current is directly proportional to potential difference across its ends. Yes, it relates. So it is true. The symbol ohm is, how do we represent the symbol ohm? See, this is wrong. This is not the way. This is not the way. This is the correct answer. Okay, so this is the Greek letter which we use to represent ohm. Correct answer is option A. Name the physical quantity whose unit is ohm. Electrical resistance, electrical magnet. Electrical resistance is correct. 27th question. Insulator is the general name of the substance having infinitely high electrical resistance. Is it true or false? Infinitely high resistance. Yes, it is true, because insulators doesn't allow the current to pass through. So current is less, resistance is more. So true. Next question. Keeping the potential difference constant, the resistance of the circuit is halved. By how much does the current change? What he is telling is we should know the relationship between current and voltage and resistance. So here in this case, voltage is kept constant, it seems. Okay, and the resistance is halved. So now we are going to halve this resistance. So by doing so, what will happen to current? This 2 will go up. So therefore it will become twice the current. So it will be doubled. Okay, so it becomes 2 times of VR. So therefore it will be doubled. Next question. Ohm's law states a relationship between potential difference and current. Potential difference and magnet. No, potential difference is current is the correct answer. Option A is the correct answer. Next question. What is meant by conductors? Which will allow the current to pass through. Which doesn't allow the current to pass through. Which allows the current to pass through is correct. That is called conductors. Example, almost all the metals. What is meant by insulators? The substance which do not allow the current to pass through, isn't it? So which must be the option B must be the correct answer. So that is the substance which does not allow the current to pass through. Insulators. Bakelite, I gave you example, no? Bakelite, high resistance it has got. So which of the following is good example of conductors? Plastic, rubber, silver, paper. Plastic, rubber, paper, these are all insulators. That is bad conductors, and silver is the good conductor. So the option C is correct. Okay, next question, 33rd question. Which of the following is a good example of insulator? So a good example of insulator is plastic, copper, silver, aluminium. So copper, silver, aluminium, they are the conductors. So plastic will be the insulator. Okay, that's right. So next, air is a conductor or insulator. If air conducts, what will happen? So if air is conducting, so right from the between the sun and the earth, so if it is conducting, then what happens? No living organisms would be. So it is acting as a dielectric. That means it acts as an insulator only. So air is an insulator, not a conductor. That's conductor is wrong answer. Insulator is correct. Next, graphite is a conductor or insulator. Graphite is conductor. Okay, it is not an insulator, because you might be knowing in chemistry, you would have studied, it is a conductor. What is Ohm's law? At a constant temperature, the current flowing is directly proportional to the potential difference across its ends. That's right. At variable temperature, no. So not the temperature should remain constant. So therefore option A is the correct answer. Option C, at a constant temperature, the current flowing through the conductor is inversely proportional to potential difference. No, that's wrong. It's directly proportional. Voltage and current is directly proportional. Directly proportional. So therefore the option A is correct. Fine. So we have 3 options. So in that A is correct. Electricians wear rubber gloves while working with electricity. Why? Because it's an insulator. It doesn't allow the current to pass through. Good conductors will allow the current to pass through. Therefore we It is not a good conductor. Rubber is not a good conductor. It's an insulator. 28th question. From the above graph, see the graph, we can find that it is the relation between voltage and current. An electric circuit consists of 0.5 meter long nichrome wire XY, an ammeter, a voltmeter, and 4 cells of 1.5 volt each, and a plug key was set up. So from that, this observation is got. Okay, so this graph is got. What would be the values of VI ratios when VI ratios means voltage versus voltage by current ratio when the potential difference is 0.8 volt, 1.2 and 1.6 volt. See here, this is potential difference when it is this is V, no? So potential difference when it is 0.8. So here is the 0.8 volt. What will be for 0.8 volt? What will be the current ratio we should find? For similarly, you have to find for 1.2. What is that you need to find? Similarly, for 1.6, you just see to it and find. So when we just divide this, when you find the ratios is what? Ratio is going to be what? Resistance. So we know that in Ohm's law, the resistance will be constant. Okay, so then which will be the correct answer? So what is the current and what is the voltage? So in this case, it is when we consider this 0.5, can we take, so see here, this 0.5, this is the reading, and for 1 this is the reading. Okay, so V by I is going to be 0.5 divided by 0.2. that means you can multiply 10 on either side, that is on numerator, not either side, numerator and denominator. So you get 5 by 2 is going to be 2.5. so the option would be 2.5 everywhere. Okay, here everywhere when we find out the resistance, when we find the slope, it is going to be the same. It is 2.5 is the correct answer. It is option B. Okay, from the above data, the values of the current flowing through a coil for the corresponding values of the potential difference across the coil are shown. Plot a graph between V and I. Calculate the resistance of the coil. So here in this, they have given the data of voltage and current. So we need to find what will be the resistance. So how to calculate resistance? The formula for resistance is R is equal to delta V divided by delta I. Okay, so when we we can plot the graph or directly from the data we can write. So here any one value we can take. So here I am considering second value. So you can take either delta V by delta I, or you can take V by I. At that particular instant, what is that voltage value? It is 1.7. So 1.7 divided by 0.1. So now you can multiply numerator denominator by 10. So we get 17 divided by 1. So which is 17 ohm. So resistance value is going to be 17 ohm. Okay. So options given are 17 ohm, 18 ohm, 19 ohm and 20 ohm. The correct answer is 17 ohm. The graph between voltage and current for a conductor is a straight line passing through origin. Which law illustrated by such graph? So we know that voltage versus current, if we draw a graph, it's going to be linear. So which law does it resemble? V is proportional to I, which is Ohm's law. So here the options given are Ohm's law, Boyle's law, conservation of energy, conservation of mass. So the answer is option A, Ohm's law. That is the correct answer. Okay. So next, the graph between V and I for a conductor is a straight line passing through origin. What should remain constant in the statement of this law? So according to Ohm's law, at a constant temperature, the current flowing through the conductor is directly proportional to the voltage applied. So therefore, which should remain constant here? Temperature. So option A is temperature, B is current, C is voltage and D is power. So correct answer would be option A, temperature. That would remain constant. If the temperature changes, resistance will also be changing. Next question. A car headlight bulb working on 12-volt car battery draws a current of 0.5 amps. Resistance of the light bulb is. So how to calculate here? What all the data is given? We need to write. So the data given is voltage and current. We need to find the resistance. The formula to find the resistance is V by I. So what is V? V is 12. What is I? It is 0.5. 0.5 can be written as 1 by 2. So 2 will go up. So it will become 24. 12 into 2 is 24 ohm. So 24 ohm will be the correct answer among these options. Fine. So next question will be fifth one. The substance having infinitely high electrical resistance is insulator. We have seen already. So conductor is the one which has less resistance. Resistor, appreciable resistance. Superconductor, zero resistance. Insulator will be infinite resistance. So the correct answer will be option D. This will be the correct answer. Infinite resistance. Next, keeping the potential difference constant, the resistance of the circuit is doubled. The current will become. So what he is telling is that here voltage we have to keep constant, it seems. So the resistance is equal to V by I, we know. So voltage we are keeping constant, we are not going to change this. And current we are what we are doing, the resistance of the circuit is doubled. So here resistance is going to be doubled. So if we double the resistance, what happens to the current? So I will become, I is equal to V divided by 2R. That means it is half of the current value. So it is halved, isn't it? So therefore we have to write the we have to choose among this. The correct answer is half. See here, V by I, V by R is what? I. So here half value we have here. So that means the current is, original current is divided by 2. We will be getting the new current. Fine. So this is done. Sixth question. Seventh question. Write down the formula which states the relation between potential difference and current and resistance. So we know V is equal to I into R according to Ohm's law. So therefore the correct answer would be option B. Option B is V is equal to I into R. A is V is equal to I by R. Wrong. V is equal to I plus R. Wrong. V is equal to I into I minus R is wrong. So correct answer will be option B. V is equal to I into R. Here in the above table, it shows the current in 3 different electrical appliances when connected to 240 volt main supply. Which appliance has the greatest electrical resistance? So they are asking which appliance has the greatest electrical resistance. So given is current. So what is the relationship between current and resistance? Current and resistance. I is equal to V by R. So here in this case, which is having the least current, that would have the highest resistance. So which is having the least current here? 0.4. 0.4 is having the least current, that is lamp. So lamp is having less resistance, so there is less current, so the resistance will be high. So high resistance which has got lamp. So option B is the correct answer. So here option B is the correct answer. Now what is the graph of VI for a conductor? So for a conductor or for anything, we know that the relationship between the voltage and the current is going to be proportional. Okay, that means they will be linear. So which option will be correct? They will pass through the origin. So answer A is correct. Straight line passing through the origin would be correct answer. Whereas B option is parallel to x-axis, parallel to y-axis. No. Curved line. No. So this is the correct answer. So correct answer would be option A, straight line passing through origin. We have discussed the various objective type questions on Ohm's law and resistance. In the next video, I'll be discussing objective type questions on circuit diagram and electric circuit. If you like this video, kindly click the like button and share to all your friends. Don't forget to subscribe my channel to get the notification for the upcoming videos. Thank you. Have a nice day.